Should be ready. Okay, we're on this page right here, guys, where we left off. Day before yesterday. We were making the table. So we were multiplying 2.25 times the x's. So what's 2.25 times 0? Then 2.25, 4.5, 6.75, and 9. Okay, we're going to go graph it, and you only need to graph 3 of them. So 0, 0. Let's graph 2. 2 is easy. 450. So that's 5, and that's 4. So 2 is 450. Right? That's 5. 450 is in between 4 and 5. And then let's do 4 is 9. Take your ID. Oh, wait. We got to talk about something first. Okay, this is the gallons, and this is the cost. Now, I want to draw a continuous line through there, so I need to do gallons of something that you buy that can be divided up. Gas. Thank you. Oh, my pins are on the floor. I don't know how that happened. So let's do gas, because we can divide that up. So take your ID, and we're going to draw a continuous line. Now, can you buy a negative amount of gallons of gas? No, you cannot buy negative. So it's not going to continue there, but it can continue up here, can it? Because you can buy, I mean, some vehicles take what, like 50 gallons, not like big trucks, whatever, take 50 gallons of gas or what, like big, or more than that. So it can keep going. All right. So now we are going to write the situation. We're going to write it in words. So we've already said that X is the gallons and Y is the total cost. So what are we going to do? What are we going to write? Well, no, we need it in words. Well, there's several scenarios. I mean, several ways we could write it. The total cost, which is Y, is 225 times the what? Well, what does X represent? No, what does the X represent? No, the gallons, isn't it? Don't you multiply 225 times the gallons? Yes, to get the total. And gallons, now we're going to put the X. So the total cost Y is 2.25 times the gallons X. Good. Now, let's come right over here, and I want to write something. K equals Y over X. Okay, so we're going to go we can take any one of these to find K, correct? Any one of these to find K. They already gave it to us, didn't they, down there? But I can take any of these and go divide it. So let's take one that's not this one. So let's do what, 675 divided by 3? No, 675 divided by 3, huh? Yeah. Has to be the 3. And what do you get? 2.25. Good job. Okay, put this in practice. And now look at your open your spiral. We're going to put this in our spiral as soon as we fill it out. Okay, we're going to put this proportional relationships. I'll have to remind you. I'm going to correct it tomorrow, but you might not. Okay, so everybody has that written down? Hey, Jay, proportional relationships. Hey, guys, don't glue it yet, okay? Let's fill it out and then we glue it. Okay. On our notes, we're going to write proportional relationships. And guys, I meant to do this on colored paper and totally forgot. Went down the copy machine and just went to copying. And then I cut them. After I cut them is when I remembered. So proportional relationships. Okay, tell me what you know about proportional relationships. What we've learned this week. They go through, they're linear, and they go through the origin. So we'll need to remember that when we graph it. Okay. What form is it in? What form? Equation. Equation form. Good, Logan. So y equals kx. So we know the equation is going to look like that. Y equals kx. It's going to be in that form. Okay. So what we need to do is go write a situation that's proportional where we give k, where we give the k. The y and the x are going to vary. They're going to change. But that k is going to be the constant proportionality. It's going to stay the same every time. But, guys, look. We have to, looking at the graph, we got to use low numbers. So we got to use like 2 or 4 for k. So, okay, Logan, give it a whirl. I might need to lead you so it'll work out. But go ahead. Oh, I'm sorry. Okay, so 2. What has like 2 in it or 4 in it? What would you maybe buy or use or something that has 2 or 4 in it? No. What thing? What something? A physical thing that candy. So if you're thinking candy, let's do candy. Okay. So who's gonna buy candy every week? John. Okay. You know what second period did? Cookie Monster. I know, I said he eats cookies, and they said, oh, he's going to eat candy now. He's changed. He's tired of cookies. Okay, so now he's going to start eating candy. So John buys packages. Of Kit Kats each week. See, we don't know how many packages, but what do we know for sure? He buys them each week, and how many? And there's what? Well, yeah, but there's there are 2 pieces in each package. I was trying to make it less words, but there's just not any. Okay? So, how many pieces? Now, let's stop and let's talk about what pieces is going to be. Is pieces? Okay, where's 2 going to go over here in the equation? 2 is going to be what? The K. Good, David. So 2 is going to be the K. So the pieces, is that going to be the Y or the X? The Y, because X is going to be the packages. If he bought 5, then he ate how many pieces of candy? 10, right? Okay, so we know that the pieces, that's going to be the Y. Will he get when he buys X packages? Because we still don't know how many he's going to buy. How many pieces Y will he get when he buys X packages? So we know that the Y is going to be the, and we're going to have to use C because we can't use P and P. So C for the candy. X is going to be the packages. So 2 times the packages gives how many pieces of candy he ate. So Y equals 2X. Good. So now we're going to come down here and make a table and then graph it. Hey, make an H table. Chart table, whatever you want to call it. X, Y. Remember, this is the packages, this is the candy. Pieces of candy. So let's use the 2X. So if you do 0, 2 times 0 is 1 week. He doesn't buy any. So he eats 0 pieces of candy. Let's do 1. 2 times 1 is 2. And then let's do 4. 2 times 4 is 8. Because, guys, you'll see in 8th grade, it doesn't always go up by 1. In fact, they don't always start with 0. They might start with -3, 8, and then go 8, then 15. They don't follow a pattern here. And that's what we'll have to worry about. They're not going to follow a pattern sometimes. All right. So, we know that the constant proportionality is what? Is 2. So, to get the constant proportionality, what do we divide? Well, anytime we divide what? Y by X. Always. And K is called the what? Constant. Good. Of proportionality. We're going to write proportionality. Well, proportional a couple more times. Okay. Now, let's go graph it. All right, let's talk a minute. Are you going to ever buy a negative amount of packages of candy or eat? No. So really, we just need the first quadrant right here. We just need quadrant 1, positive, positive. So this is the packages, just abbreviate that. And this is the candy pieces. It's kind of hard. Let me make it bigger now, this section. Okay, so we're going to go graph. We're going to go graph 0, 0, 1, 2, and then 4, 8. Now, are we going, now we know it's going to start at 0, 0 because you can't have negative amount. You can't have negative. Then, and it's going to go up. Okay, are we going to, can you buy a part of a package of candy? No. So we're going to have to do a dashed line. We're going to have to make it dashed. It's showing that it's linear, guys. It's showing that it's linear, but we can't make it a solid line. Only the whole numbers are going to be a solution to this question. Only where it does whole. So 2 would be 4, 3 would be 6. But we can do an arrow on the end. We can do an arrow on the end of it because it can keep going. Okay. Let's see if I need to put something else on there. I don't think so. All right. Glue that in. And then if you borrow my glue sticks, or the glue sticks over there, go put them back. You don't have to. I think it'll fit. I cut it. I thought so. I cut it where I tried to where it fit. Okay, page 8. Yeah, just on the right side. Okay, guys. Hurry. Hurry, glue. Playing football and PE. That's what I said. Okay, everybody. The Chance family drove 200 miles in 4 hours. 200 miles in 4 hours. What is the unit rate? What is the rate they were driving?
200 miles.
50 miles. So what did you divide? Good. So you want to divide the miles by the hours. So you're going to go divide 200 by 4. We're getting the unit rate. What is another name for unit rate? Constant of, say it louder. Good. So constant of proportionality, where you divide the y by the x. So the miles, guys, think about this. Would you be going hours per mile. Would you be trying to figure out how many hours you went per mile? That'd be like a turtle. Hours per mile. You see? So it's miles per hour. So the miles is going to be your Y, and your hours is going to be your X. Doesn't that make sense? Okay. So we divided 200 by 4 and got what? 50. 50 is our what? Constant. Yeah, y'all are getting all the words all together. You're right, but it's constant proportionality and unit rate. Okay, those are the two names for this 50. Okay. Okay, does everybody understand that? So, since there's a constant proportionality, then we know we can write it in this form. Y equals Kx. So what is K? K is 50. So we know we're going to go multiply the X by 50 to get the Y. But you need to be able to intersperse the variables. So I want to do 50H right now. 50H. So I'm going to go 50 times 0 and get 0. Keep going all the way down till you get to 5. Okay, does everybody get what I got? Good. So, where does the unit rate appear in the table? Where does the unit rate appear in this table? In the process column. It's in the process. So every time we multiplied by 50, that stayed constant, didn't it? That stayed constant. So how are we going to write the rule using the M and the H? Now, how are we going to write the rule? What did we do to get the Y, the M? What did we multiply by? Now, what did we do every time? We multiply 50 times H. We multiplied 50 times H. Good job. Okay, now what we need to do is go graph it. So, guys, we need to set this up. The graph is kind of small, so I want to spread it out a little bit, and I don't want to number 1, 2, 3. So, an hour, can an hour be divided in half? No. An hour? Yeah. What about thirds? 20 minutes? 3 20-minute sections? Yeah. So can you divide it in fours? 15-minute sections? Okay, what about in fifths? 6? Not 7, not 8. What about 10? I mean, you can divide it in any, by any way. I'm talking and getting a whole number, right? So what I want to do is divide it into fours. So you're going to count every fourth one. So 1, 2, 3, put a 1. Yeah. 1, 2, 3, put a 2. Keep going till you get to 5. Okay, so now counting up, I've got to go by 50. I got to make sure I, go by 50, 100, 150 needs to be over there. So they're so small, we did every other one was 25, first and second period. So every other one, you're going to count by 25. So you're really counting by 12 and a half, aren't you? So that'd be 50, 75, just count to 200. Be fine. And then we need to put 3 of those points on the graph. So 0, 0 would be good. We only need 3, and let's spread them out a little bit. So let's do 1 is 50. And maybe 3, 150. And we already discussed that we could divide an hour up into whatever we wanted to. So we're going to do a continuous line. Put your ID down, and you're going to have to move your ID. Okay? Now, we already knew it was proportional, but now we have confirmation, don't we? That it's proportional. Okay, what are the 3 reasons it's proportional? Tell me, what'd y'all say first? Okay, so let's put linear and goes, and we're going to use the slang for through. That's not how you spell through. Through, let's put the origin. Make it sound a little bit more intelligent. Okay, number 2, we did what's the first thing we did on this problem up at the top? What's the first thing we did? Yes, we got the constant proportionality unit right. And so we already divided 200 by 4, but let's go ahead and take 50 and divide by 1, and we got 50. You could have taken 150 divided by 3. There's several. But you're going to take a y and divide by an x. See, we're not trying to prove it's proportional. We already know it is. We're just trying to say what the constant proportionality is. And then 3, what form did we write it in? Y equals, I was writing it, y equals kx. We could write in this form. We wrote m equals 50h. Guys, you know what they do sometimes? They'll give you 4 equations and say pick the one that's proportional, that has a proportional relationship. They'll give you 4 equations. You have to pick the one that it looks like this. Now, it might not have a y and an x. It won't have a k. You don't have a number for a k, but it'll look something like this. You have to know that that's proportional just by looking at the equation. Okay, we good? Okay, one more thing we need to do on this page. Everybody go to the top, and we're going to look at something different on this table. Now we're going to look at the change in y and the change in x. We're going to see how far does that go up. So what does it go up from 0 to 50? It goes up 50. What does this go up? 1. So what we're doing, guys, is something different that we're about to learn. We are going and doing the rate of change. This is what determines if it's linear. This is what determines if it's linear. So we're going to go and, hey, look how you write it. You put a triangle. Change in y over change in x. So you got the change in y over the change in x. So 50 over 1 is 50. Uh-oh, do y'all see something? The rate of change is the same as the constant of proportionality. So if it's proportional, guys, the rate of change and the constant proportionality, the unit rate, all that's going to be the same. If it's proportional, are y'all hearing me? If it's proportional, then that 50, that K has 3 names. Constant proportionality, unit rate, rate of change now. The rate of change, do you remember what y'all told me the first day? Somebody told me in here. It was linear because it went up the same every time. Remember the 3 miles was 1 league? And y'all told me, well, it went up 3 every time. Well, this goes up 50 every time. That's what makes it linear. Does that make sense? Okay, turn on the back. Goodness gracious, look at this one. What do you notice right off the bat? It's non-proportional. This last time we're going to write proportional today. But we got to put non in front of it. It's non-proportional. But what do we know that it is? What can we see that it is? Linear. I see that it's linear. Don't you see that? It's linear. So the first reason, though, that we know it's non-proportional is does not go through origin. Okay? Now what we need to do is fill in our table. And if you know, don't say anything out loud. I want everybody to get a chance to figure this out. But 0 is what? Tell me that. 0 is what? 30. I don't know what 1 is, or 2, or 3, or 4, because they're a little bit off the, mark here. But I know 5 is what? What's 5? 70. No, 5 is 70. So this is what I didn't want you to say out loud. Since it's linear, we know that it's going to go up the same every time. So that's what I want you to, I'm going to give you about a minute to try to figure out what it goes up every time. Go. Okay, what did it go up? 8. Woo! Good, Daniel. It went up 8. Oh. So, hey, you know what I did? You know what I did? I said, well, it went up 40 gallons in 5 hours. So it went up 8. So that'd be what, 46? Great job, guys. So this went up 8 and this went up 1. Now, pretty soon, I already said this, I believe, but pretty soon it's not going to go, you know, like 0, 1, 2. They'll try to trick us. Okay, so the change in y, let's get used to writing this, over the change in x is 8 over 1, which is 8. Now, 8 is not the constant proportionality because it's not proportional. It's the rate of change. It's the rate of change. So, what would y'all tell me it did? The graph, it went up what? 8 every time. So that's what you're going to multiply the hours by. The rate of change is what you're going to multiply the hours by because you're telling me it goes up 8 every time. But there's one slight problem. It didn't start at 0. What did it start with? 30. So let's see if that works. What's 8 times 0? 0. Plus 30 gives me 30. So 8 times 1 is 8. Plus 30 gives me 38. 8 times 2 is plus 30 gives me 46. And you just need to test 3 of them because we already know it's linear. We're not trying to prove it's linear. We already know it's linear because we can see the graph. We're just trying to prove this is the equation that gets me the volume. So to get the volume, I'm going to multiply 8h plus 30. So let's come over here and look. What's the second reason that it's not proportional? No, we've already said that, didn't we? Look at k equals yx. Let's do that. Let's take a y. We can't divide by 0, so that's out. 38 divided by 1 is, isn't it 38? Yeah. And then let's take 46 and divide by 2. That's what, 23? Does 38 and 23 equal? So there's no constant proportionality. You can't divide the y by the x and get a constant. It's not going to happen. It's not going to be the same. And then the third reason is sitting right there. It's got to be in this form. Everybody knows that, huh? It's got to be in this form. It's got to be in that form right there. So, but it's in this form. It's in that form right there. Look, it's in that form. So that's not going to work, is it? No, that's not going to work. That is not going to work. So, K is not 8. But look, you got a plus 30 right there. You see the plus 30? That ruins it. Because you started at 30 and not 0. It's got to be in this form. So, I guess just put not right there. That'll be good. Not in that form. Because of that plus 30. Okay. Are there any questions? Are you getting this? Okay, put this in practice and look on page 65. Yes, ma'am. That means change in. Oh, okay. The change, that's the change in y over the change in x. We're about to do some more of that. So just hang on. Okay, I want to say this real quick before we go. We only got a couple of minutes, so look on page 65 real quick. Page 65. So we can end on that note. Because Brooke asked a good question. Look, on this, she keeps the number of lawns she's mowed and the money she's earned. So we're going to, this is my X, this is my Y. The amount she earns depends on how many lawns she mowed. So what we're going to do is find the change in Y is what? 30. And the change in X is 2. So the change in Y, we're not dividing Y by X, we're doing the change in Y over the change in X. So that's going to be 30 over 2, which is 15. And then if I do these, that goes up, what, 45? And that goes up 3. So the change is 45 over 3, which is also 15. So these are the rate of changes. Wait, guys, that is the rate. That is the rate of change. They're the same. That's 15. Okay, now you go.